Hello everyone and welcome to the new session. In this video I'm gonna explain the LISP protocol or Locator-ID separation protocol. Before to explain that, we need to know why they invented. As you know, in the internet routing table has grown exponentially with a BGP protocol or protocol of internet. Right now is managing over 800,000 prefixes. As you can see, this is the curve represent the growth of BGP table from 1994 to present. To handle these routes or these prefixes, you need to have enough resources, okay? So what is the LISP? LISP as definition is Locator-ID separation protocol separates endpoints ID from a routing locator, improving scalability, mobility, and routing efficiency by reducing large routing table. So the main rule of using LISP, this is to reduce what? Reducing large routing tables, okay? And also in the traditional IP has two main functions, okay? The first function is the router ID, and the second thing, the location or where is the these networks located, okay? So in the LISP, separate these two separate functions. The first one is endpoint identifier. This will be assigned to the local equipment such as servers, hosts, printers, and IP phones. And also we have the second function called the routing locator. So router locator, it represents the location of the device and connecting endpoint to the internet networks. So in this case, if we give an example right now, let me bring the laser pointer. So here, as you can see here, we have three routers, and we have this network 100-100, and we have 50-50. Let's suppose this is two servers, and these two servers wants to reach each other. In this case, you have many options. The first option to enable the routing, static routing or dynamic routing. Let's suppose you are using the OSPF. So here you need to advertise this network, and also here this network, and this here in this router, this network, and this network, okay? If you are using the VPN or GRE, so you need to do, for example, a tunnel from here to here, okay? Then you need to enable also the routing table, the routing protocol or a static route, okay? So in the LISP, we don't need to advertise these networks, okay? The only thing, I will create a tunnel from here, okay, to here. In fact, it's not tunnel, it's like tunnel, okay, but it's not tunnel. We don't go to in the configuration and create the tunnel and so on. I'm just simulated, okay? So the thing is what we gonna do. So right now we have here, it will be have here a router as what? As a mapping server. This mapping server has all the info about what? About these endpoints, okay? About these endpoints and where is located. Let's give an example. Let's suppose this router, this is, for example, in Amsterdam, okay? And this router, for example, in Paris, okay? And this network wants to reach this network. So here we have another router called what? Called the map server. The map server knows all the info about the Paris network here, local network, and about the Amsterdam network, what? Network or local network. So now when we enable LISP, the first thing we gonna inform the map server about what? About my endpoints and location, okay? And also in that side. So if this 100-100 wants to go to 50-50, we goes to request the map server and ask him, please, where is 50-50-50 located? Now this server will what? Will reply and say, if you want to go to the to 50-50, you need to go to this location or routing location here. So now we'll be encapsulate these packets, okay? Then go like this, then decapsulate, then you will need after that you need to reach 50-50-50, okay? This is the idea of the LISP. The LISP is a map and encapsulation protocol. Use UDP port 4341. This is for the data packet, and 4342. This is for what? For control packet. Let's explain it more. But before we explain it, we need to know what about LISP terminologies. So endpoint identifier, this is the represent what? The entity of endpoint device. In this case, this is our server or host, okay? Then the routing locator, as we said before, this router or this routing locator is the router or represent location of what? Of endpoint, okay? And here we have the ingress tunnel, okay, 8 ITR, and we have the ETR. So the ITR, so what does it mean? The ATR is located the source network. This is the source of the network, okay? So if you back here, so this is the ATR. This router represent as ATR because it's going what? From here to here, okay? This is the ATR, and we have the ETR, okay? The egress one. This is the router called the egress ATR, okay? Let's back here. We have also the map server. This map server, this is the database of what? Of endpoint and routing locator. This is the map server. This is called map server. And we have also map resolver. So what is the map resolver? This is another router, or it can be also router act as MS or map server and map resolver. Map server has all the database about the endpoints and routing locator, right? What is the idea of map resolver? So map resolver, so let's suppose I have here a router, okay, and I have a server here connected here, and then I have another router here connected to another server. This is act as ATR, okay, see the ATR, and this is what? ETR. Okay, good. So now if let's suppose this is 1111 and this is 2222. Okay, now if 111 is going to 2222, okay, first of all, before this traffic generated, so already we have another server called what? MS. This MS include all the database, because when you are enabling LISP here and here, this router will advertise what? His endpoints would say 1110/24 plus what? Plus the ATR address. The ATR address, let's suppose here we are using 11001. Okay, so here we say 11001, and also the ATR with what? Will send the database to MS. Okay, and here we say my endpoints, okay, is 2222 plus what? Plus the ETR, or ETR is the ingress, is my ingress is, for example, 12001. Okay, so here let's suppose we have the internet in the middle like this. Okay, good. So now if 11 want to reach 222, okay, so here this request or this router check the routing table, check routing table looking for 222 if exists in my routing table or not. If not, he will find the LISP is enabled. So in this case, we'll goes to another router, okay, called what? Called the MR, or the map resolver. This map resolver is, this request is going like that and ask about who is 222, how can reach this 222. So the MR here will ask the map server, okay, to get the info, okay, then the MS reply to the MR, and the MR reply to what? To this router. Then the MR already has the info from the MS. If you want to go to 222 networks, you need to go to the routing locator called 12001, okay, then will be forward now encapsulate the packet, and it goes like that. Okay, so in this our example, usually you will find what the MR, it's the same router as map server. Okay, so you can use as a separated. For example, you have two routers, one map resolver and one map server, and another one what is map server, or another one is map server. And also you can only use one router and act as map server and map resolver. This is the idea of the map server and map resolver. Sorry, I hope this is clear. So now let's go to the communication in the Lisp. So I will explain it more. Okay, as you can see here, we have the server. We have two servers connected to this router, to this internet, and so on. First of all, we have this router act as ATR, okay, and the other one act as ETR. So now if we generate the packet from this, for example, I ping or something like that, so this will be act as ATR, okay, and when this server is reply, so the rule will be changed. So will be this router will be as ATR, and this one will be ETR, because when we said ATR, we will encapsulate, then send it, and here decapsulate, and this server one be the reply. So here I will encapsulate, it means ATR, and goes back here, and decapsulate is called ATR. That's why I use the XTR. Okay, so this is on general. First of all, let's suppose we enable the Lisp here in these two routers. What's going on? First of all these two routers inform what? Inform map server by using the map register to register my database where in map server. So I would say I have a prefix called 100.100.100/24 plus routing location is 11.0.0.1, which is this interface. Okay, and also this router will inform the map server, okay, the map register, please register the endpoint prefix 50.50.50.0/24 plus routing locator, which is this interface 12.0.0.1. Okay, this is the first thing when you enable the Lisp. Now let's imagine we have 100.100.100, okay, wants to reach 50.50. So first of all, now before we going to that, when you send the mapping register, okay, so map server will map notify. So this is like a confirmation. So already I map or I store this your info in the router. Okay, so now let's suppose 100.100.100 wants to reach 50.50. So the packet is going as a source 100.100.100 and destination 50.50.50. So the packet reached this router, sorry, and this router checking the routing table and try to find 50.50.50. Now he discover that this network doesn't exist. So and discover the Lisp is what is configured in this router. Now this router will send what? Send a map request. Map request to what? To the MR, to the map resolver, and ask where is 50.50, how can reach 50.50. Now this map resolver ask what? Ask the map what server where I can find 50.50, and map server already knows about what? About the ID prefix 50.50 and where is the located, the address is 12.0.0.1. So now map server reply to MR and the MR reply to what? To the router. So here when this map reply to the router, now the encapsulation start here. Okay, start and goes to what? To the other router, and this router will be encapsulate and this is decapsulate. Okay, this is the thing also, if this server reply it will be the same thing. Okay, this is about what? About the communication in the Lisp. To get it more, so I have also another example. I have these two servers. Okay, first server has what? We have here first, we have the ATR and we have ATR, okay? And here I have EID 11, okay? And the server 22. So first of all, the EID here will send what? Send all the map register. As you can see here, this ATR will send the map register 2220/24 plus what? Routing locator 11002. So it means this is 1102. Okay. So now here the first step, we have the source 111 wants to reach was 2222. Okay. And this is, we have the original data. So now this packet is going to the router 1. And we have the map cache here. The map caching is set 11110/24 is routing locator 12001. This is the first one. The first thing, the R1 is send the query to MR. Is going to the map resolver and ask about 222. If you know any info about the 222, so this map server already informed the map resolver and say if you want to go to 222.0/24, you need to go to 1102. And here we have this routing locator is 1201, and here we have 1102. So now the MR will be reply and say if you want to go to 222 to this server, okay, if you want to go to this server, let me bring the pointers better. If we want to go to this server, okay, go to 11002 and you will reach this server. Okay, that's great. Now what's going on? So now we'll encapsulate these packets, source 111, destination 11, via the source IP 1201 and destination 1102. Now is going to what? To router 2. After we going to router 2, now decapsulation is happen here, okay? And happen here when you remove these two source IP and destination IP. So I will found what? I found what? The original one, which is the source IP 111 and destination 2222. When we reply, it will be the same thing. Okay, this is about how can the LISP communication happen. Okay, as you can see here, we have the LISP header. LISP header, we have the outer LISP source IP. Okay, this is the in our case is outer. This one is 1201. And also outer LISP destination. Destination will be 11002 in our case. Okay. For the port, the source port, the UDP source port will be randomly generated from the router, and the outer LISP destination UDP will use what? Use the port number 120. If we going back to our here, will be used what? 4341. Okay, this is for what? Encapsulation and decapsulation. And 4342, this is the port used for what? For between the ATR and ETR to communicate with the map server and map resolver. So if we going back here, so this communication, the ports here will be used 4341 here between these two server for encapsulation and decapsulation, and communication between the MR and the map server, it use what? It use the port number 4342. Okay, this is about the header. And here we have the LISP header. The LISP header in the middle, this is include instance ID and other info. Okay, and also we have here the original IP source, which is in our case here is 111, and destination 1, and destination 1 is 222, and we have the data. Okay, this is, and also if we're going to routing locator and EIDs with IPv4 and IPv6, the good thing is also support support what? Support if the IPv4 or routing locator support IPv4 and the endpoint is IPv4. In our case, in the last example is the same. And also we have support IP if the routing is IPv4 and the endpoint using the IPv6 is supported also, and also support if the routing locator is IPv6 and the EID is IPv6, I mean the endpoints using the IPv6, and also if the routing or in the middle routing locator using IPv6 and the EID using the IPv4, it's supported as well. This is LISP header in the Wireshark. Already I took this this picture from the Wireshark. As you can see here, we have the Ethernet source. Okay, we have the Internet protocol, which is 12.1 and 11.2. Okay, the port as you said is 14.4341. Okay, and this is what 111 and 222. This is the original one. This is the original data. And this is for the LISP, okay, encapsulation and decapsulation, and this is the port. Okay, this is about the LISP. I hope so everything is clear. In the next video I gonna show you how to configure LISP in the lab. Thank you so much for your watching and consideration. See you in the next video.